Today I'm going to show you exactly how heat works at my expense. Here's one broken radiator, it froze. Here's another heater that broke. These froze completely. We are upstairs, upper level. Here's another one that broke. Here you can see it very clearly where she cracked. She froze and broke. It's cast iron, so it's a weak part. Here's another one. You can see where she cracked right here. She froze and broke. Now a lot of people are going to question what's going on. Doesn't heat rise? Yes, it does, but it also goes out the roof at a far greater pace than it does anywhere else. So once the heat shut off, the energy is going up. Now up above there, I'm going to show you, we have far more resistance to the heat flow than any CO2, water vapor, anything in the atmosphere that there is. Far greater. So let me go show you that. So up here, as you can see, we got a ton of insulation. Okay, this is far more of a resistant value than anything you're going to find in the atmosphere. How deep is it? You can see there's well over a foot of insulation up there. That's far greater than any atmosphere. Now, as soon as I opened that lid, you could feel the cool air just descending. It was coming on in and the heat was escaping right out of it at a rapid pace. Well, what happened is that the furnace shut down and the house began to cool. So why did the upper levels freeze first and the lower level did not? The reason is because your heat loss is greatest because heat rises and cool air descends. So the whole house was heated, and this of course lost its heat first, causing the radiators up here to freeze and crack. The heat was retained down at the lower levels and prevented it from cracking. Just like at nighttime, the heat ascends away from the earth. Just as the heat ascended from this radiator, cooled the radiator first, froze it, and cracked it. Now what I did do was ask the heating guy, why couldn't we just heat the upper level and just blow the heat down? He looked at me with a confused look, like I was crazy. And I looked at him and said, that's right. That's what the science says, is that basically that circulation forces the heat back down. No, it'll come right back up. What we're going to do is we're going to be able to see that it's going to heat up here first. Now our heat has to be greater than the loss, and then the heat is going to begin to build down. And she's going to build down until the bottom line in the downstairs becomes heated. But we also got heat on the main level, so it's going to come to what's known as equilibrium. But our heat has to be greater than our loss. And this is just evidence of basically that no matter how much resistance you have, you're going to lose it once the heat shuts down or when the sun goes down. This is kind of clear-cut evidence as to how heating works and why CO2 and heating the upper level is not going to drive heat downstairs. And that's why we put a heater downstairs, was basically to help keep the water pipes warm down there. Because the heat was down here in the entire house, it lost its heat at a slower pace than it did upstairs because, of course, heat ascends and will be driven upstairs until it gets lost so much that these would have eventually frozen too. Right now, to help keep it warm, I've got space heaters in this. Basically what we're talking about here is what's called thermal absorption or thermal capacitance. That this level was heated and it took longer for the cold air to descend to come on down because it was losing it so quickly out of the roof. You can see here, this is the boiler. Just like what we have down underground. Basically this is what happened is the fan went out and wouldn't cool it down, and it caused it to shut down And basically all it does is it sends the heat. Originally it was just gravity flow, just like the Earth, and it would use the heated water to move up one line, and then the return line comes back on down, and it's just basically a radiator. And that's how a boiler system works, especially the old boilers. And right now what we have is a space heater here, just helping keep the boiler warm so that it doesn't freeze. Reason is basically if you've got a living area downstairs, what you want to do is you want to be able to shut your door to trap the heat in. But I was told that while it's cold, and one lady said that she keeps the door shut because when she opens it, she feels cold air. Well, what happens is that it's called displacement of air. When you open the door, the heat's going to rise on up and then come on down. And of course, this cold air now has to go somewhere, so it's going to come down and it's going to come right into the house. So that's why you close the door during the summertime with the air conditioning to keep the cold air from descending down into the basement. Or you shut the door if you've got the basement heated because you want to trap the heat in downstairs. But what happens is that the heat will build to a certain level until equilibrium is hit with the main level. And that cold surge is only going to be temporary because it's got to go somewhere. And then it equalizes. Thermal equilibrium. Can't get around it. So next time you have your heating guy come over, you just kind of feel that heat radiating. Ask him about heating the upstairs and getting a fan and blowing it down and heating the basement. Take a look at his face. You'll understand.